So we're now moving on to our last part of the year that we're going to be learning. And remember, we're not going to be assessed on this, but this is something that's really important for you to be able to be successful next year in high school. And that's going to be multiplying binomials. So even though we're not being assessed, make sure you're still putting in the work, the practice, and the effort to make sure that you have this down because it's only going to be beneficial for you in the future. And our learning objective for this video is this: students will know how to multiply two or more binomials together. So at the end, there might be one where we're doing more than just two binomials that we're multiplying together, but you'll have to know how to multiply binomials. All right, so let's go ahead and get started. Well, if you're going to be multiplying binomials together, you'll have to know, well, what is a binomial? And a binomial is an algebraic expression with two terms. And we've talked about what terms are and how we know if there's one, two, or three terms earlier in the year. But remember, terms are separated by addition or subtraction. So if I give you this xy, this is just one term because those are just two numbers that are being multiplied together. And if we knew what x and y were equal to, it would just give us one number. For instance, if x is equal to 2 and y is equal to 3, this x times y doesn't represent two different numbers. It actually just represents the number 6. So when we see just multiple variables or numbers, it doesn't necessarily mean that there's more than one term. They must be separated by an addition or a subtraction. So x plus y is two terms. X minus y is also two terms because here it's representing two different unique values. Yes, when we plug them in, it's going to end up giving us just one number after we go ahead and solve for it anyway, but they're representing two unique values there where the one before, we're just multiplying those two numbers together. So they must be separated by an addition or a subtraction. And terms can look in, binomials can look in different ways. It can be 2x plus 4y. It can be 3xyz minus 6abc. It could be multiple variables and numbers within each term. But once we see that it is chain or it's separated by an addition or a subtraction, then that means it's a new term. So here we have one term, and here we have our second term. Here we have one term, and here we have our second term. And that is because they are being separated by an addition or a subtraction. All right. And we can have more than two terms as well. We can have trinomials, which is three terms. We can have four terms and so on. So if we were to add another addition or subtraction to here, and let's say plus 5x, well, this will then give us three terms. We would have one, two, and three terms. So we're just going to be focusing now on multiplying binomials. All right, so we have learned this year and in previous years as well that when we see 5 next to the parentheses like this with the 4x minus 2, this is telling us that we need to multiply. And we know that we need to distribute this 5 into both terms. So we're multiplying here a single term, which is called a monomial, and a binomial. So we're multiplying a monomial with a binomial or a one term with two terms. And we know that we have to distribute. So 5 times 4x will give me 20x, and 5 times negative 2 will give me minus 10. We use the same thought process and logic when we're still multiplying binomials. So if this were to change, instead of just saying 5, if we were to change this to x plus 5, and let's say we're just multiplying it by x minus 2, just to make it a little bit easier for now, the same thing, the same thought process and logic happens, meaning that when we see the two parentheses written next to each other like that, that's telling us that we're multiplying. And just like we needed to distribute this 5 in to both terms, we need to distribute the x and the 5 in to both terms. So I'm actually going to go through 3 different methods for you to do this. The first one I'm going to write out, we'll say is FOIL. The second one I'm going to use arrows. And the third one is going to be using a table. And this is actually the one that I'm going to suggest that you'll use in the beginning. So I might actually do this one first, do this one second, and then do this one third. Yeah, that's the order that I'll go in. I'll go from table, foil, and arrows. I do think that until you guys get a full hang of it, the table is the best method to use because it will allow for you to check for any mistakes if you miss to multiply something or if you actually multiplied the same thing twice by mistake. So I think the table is the best method to go until you guys feel really comfortable and confident. And then from there, it's probably the arrows. All right, so let's go ahead and go through all 3 of these different methods with multiplying x plus 5 times x minus 2. All All right, so for all three of these examples, we're going to multiply the same two binomials together, x plus 5 and x minus 2. If you guys in science have ever used a Punnett square to figure out maybe like what the genes would be of a baby, that's essentially what we're going to be using with the table as well. So what we do is we take our two terms or the two binomials that we're multiplying, and we're going to write them out, just spacing out our numbers a bit. And we're going to write one horizontally. So x plus 5, I wrote it horizontally. And I'm going to write one vertically. And when you write it vertically, put the sign of the number directly in front of our term there. And then we're just going to create a table here separating all of our different terms. And whatever you have as your sign, put it within that table so that this way you don't mistakenly change a positive to a negative or a negative to a positive. And when you create this table, what we're doing is we're generating each number within this table by multiplying the two values that we have in the row and the column. So this part of our table here is generated from the x and the x. So we multiply them together and we get x squared. Then we see that this table, part of our table, is generated from the 5 and the x. So we will multiply 5 times x, which then gives me 5x. Here, once again, we look to see, okay, well, what is generating this table, or this part of our table? And we have an x times -2, so it gives me -2x. And then our last part of our table that we're missing here, we see it's generated from the 5 and -2, so we multiply them two together, get -10. Now, the nice thing about a table is if anything is going to simplify and add together, then you'll see they actually are written diagonally from each other. So you don't really have to go searching like you might in FOIL or arrows to see what is going to combine. It's nice and it's written to you nice and neatly where it's just going to be these corners that you'll follow. You should still be checking all your tables in case that you write it a little bit differently. It might change up the order of it, but if you're writing it from descending order of x and 5 and x and -2, anything that can be combined will be diagonal of each other. So once you multiply this out, the thing that's good about the method with the table is, one, you'll fill in every single block. So you'll know, did I miss multiplying something? Or sometimes students will multiply the same thing twice. Well, there's no space for you to multiply the same thing twice. So it's allowing you to make sure you're not making any mistakes. So when you're getting started, this is probably the method that I would suggest because it's allowing for you to kind of check your work as you go. And once you start getting the hang of it, you'll probably start using the arrow method later on. But then after we multiply, we just need to go ahead and add everything together that we can. Well, there's no other x squared, so there's nothing else I can add with that. So we have x squared. Here we see we have a positive 5x and a -2x. So 5x minus 2x is going to give me plus 3x. And then there's nothing else with our constant -10, so it's just going to be -10. So x plus 5 times x minus 2 gives us the answer of x squared plus 3x minus 10. So it's the same thought process that we had when we were multiplying this 5 times x minus 2, where we were distributing the 5 in. But now there's two terms that we need to make sure that we're distributing in. So that is the first method with the table. And now let's go ahead and show you using FOIL. All right, so now the next method that we're going to go through with multiplying this is going to be our FOIL method. And these are all essentially the same thing. It's just different ways of distributing each of our term in. One of them is a little bit more visually with the table because it's guaranteeing that you're not missing anything. And this FOIL is a little bit more of just like going through a step-by-step process. And then the arrows is kind of FOIL without writing it out. But when we say FOIL, what we're meaning is the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So this is telling us what to multiply. So when we're saying the first, we're saying that we're multiplying the first term in each binomial. So that means we're multiplying the x and the x together, which then gives me x squared. When we say the outer, it's meaning if we're looking at these as a stream of numbers across, we're taking the two outside numbers. So we would then multiply x times -2, which then gives me -2x. And then when we say the inner, we're talking about the numbers that when we look at these numbers as a string of numbers across all four, we're taking the both inside numbers. So these will then be our inside numbers. Let me rewrite this instead of a green. Let me write this as purple, just to match the color that I'm multiplying with. So when we say the inner, we're talking about the two inner numbers if we look at them as all four as a string of numbers across. So that would then give me a 5 times x, which is plus 5x. And then when we say last, we're talking about the last term or a second term, if you want to call that, in each binomial. So that means we're looking at our 5 and our -2, which then gives me minus 10. Right? And then the same thing, after we multiply, we still need to go ahead and make sure we're combining all of our like terms together. So we have x squared, then we have minus 2x plus 5x, which we already know is plus 3x, and we have our minus 10 that there's nothing that can combine. So we see even if we use FOIL or the table method, we are still getting the exact same answer. So it's up to you of which preference you would like to use. I am going to stress I think you should be using the table in the beginning, but some people get caught up in how to write out these binomials like here, and they struggle with that. So if you do, then FOIL could be the one that you would use. I don't suggest using the arrows until you get really comfortable, because that's where you can kind of make some mistakes. But if you write it out, FOIL, it's telling you exactly which ones that you need to multiply. So it's sort of like the table, but the problem is some students might mix up outer and inner, and they might multiply the same thing twice. So that's where we can get a little bit, have some issues or mistakes with that. All right, so now the last method we're going to do is just using arrows. And as we've done before, when we're distributing that 5 in, as I showed you, we draw the arrows and we actually multiply. So that's just what we're going to do here. We know that when we're multiplying two binomials, we need to distribute both terms of the binomial in. So I'm just going to draw my arrows in. I'm distributing the x. So x times x gives me x squared. X times -2 gives me minus 2x. 5 times x will then give me plus 5x. And 5 times -2 will then give me minus 10. And then we're going to combine our like terms just like we have in all other examples. So x squared plus 3x minus 10. So regardless of whatever method you use, you will get the same answer. The problem with the arrows, and why I'm going to suggest that you do it last, is what happens is students will see a problem and then they'll just draw the arrows right away. And they go like this. And then from there, then they go to multiply. So by drawing the arrows right away and multiplying second, you're giving yourself a chance to make mistakes because you're not doing it as you go. So you might forget to multiply something together. You might multiply something twice a little bit more easier because you're not actually following like a set pattern of the FOIL or your table that you're filling in. Especially when we get into bigger problems where we will learn how to multiply a trinomial with a binomial. So once we get into some of those bigger problems, the arrows make it a little bit harder unless you actually draw the arrow, then multiply. Draw the arrow, then multiply. All right, there's going to be two more examples I'm going to go through with this. I'm only going to use the table for the one, and then I'm going to show you a different way, or show you how you would multiply a binomial and a trinomial at the end. All right, so the next one that we're going to do is x plus 3 squared. And remember, when we see that number is squared, that is telling us that it's x plus 3 times x plus 3. So we're multiplying that same binomial twice. So we know that we can expand that out. So if I'm going to multiply this, well, I'm going to draw my little table. I have x and I have plus 3. And then since it's the exact same one, I'm going to have the x and plus 3 here as well. And remember, I'm creating the table so that my numbers are with the variable or with, that the signs are with the variable or with the number. Now I'm just going to multiply each table. So x times x gives me x squared, and x times 3 gives me 3x. X times 3 is also a positive 3x, and then 3 times 3 is 9. I know that when my numbers are going to add in a table, they will usually, most likely, 99% of the time, be diagonal of each other. So now I have x squared. There's no other x squareds. I have 3x plus 3x, which is now 6x, and then I have plus 9. So that will be our final answer for that. Regardless of which method you use, table, FOIL, arrows, it doesn't matter to me. Your teacher next year might force you to use a specific method, but as long as if you understand what you're doing while you're doing it, any of the methods will get you the same answer. Right, now what we're going to do, though, is we're going to take this answer, this x squared plus 6x plus 9, and now we're going to actually multiply that one more time with x plus 3. So now we're, instead of doing x plus 3 squared, we're actually doing x plus 3 cubed, because this we know is the answer of x plus 3 squared, and now we're multiplying it one more time with x plus 3. So I want you just to learn how and see how to do this, because there's something cool I want to show you guys in class later on. All right, now when we're multiplying a binomial and a trinomial, we can still create our table. So I'm going to go ahead and just create this as a table. So now we have the x squared plus 6x plus 9, and then we have x plus 3. I'm creating my table. And once again, I'm just going to fill in my table through multiplication. So x squared times x, this time we know is x cubed because we're adding those powers. 6x plus times x is now going to give me 6x squared. 9 times x is now going to give me 9x. As I move down, x squared times 3 is now going to give me 3x squared. 6x times 3 is now going to give me 18x. And 9 times 3 is 27. And you see, the same thing happened. When we're still using a table, the majority of the time, our numbers that we are going to actually have to add and simplify with each other are diagonal of each other. So when you're using the table, it does usually work its way out to be nice in that sense. So now we have x cubed, where there's no other x cubed, so we have x cubed. We have 6x squared plus 3x squared, which is now going to give me plus 9x squared. We have 9x plus 18x, which is now plus 27x, and we have plus 27. All right, so that would be our final answer of multiplying a binomial and a trinomial. So you could still use your table. You could still use your arrows for this, but FOIL does not work because we have more than just 4 things that we're multiplying together. So either arrows or a table would be what you would use for this one. All right, so when we're in class, I'm going to show you guys something that I think is pretty cool of how you can actually expand these binomials a little bit faster when they're being raised to the second, third, or higher power. All right, so that's it for this video.